Everyone, welcome back to another lecture at my channel Easy Chemistry. To begin with, I know that there has been a long gap in posting videos one after the other, but gradually things will come back on the normal routine. So, bachon, today we are going to just briefly talk about Introduction to Organic Chemistry. Introduction to Organic Chemistry is a very long portion, and as I repeatedly keep saying that your base or your concepts need to be strengthened at the start and not at the end of it. So students, organic chemistry or organic. As the name suggests, organic, it refers to anything or everything that is synthesized by living beings or any organism which possesses life. So anything which has life can make any compound, and that compound or that material is termed as organic chemistry. However, in around early 1800s or towards the middle of 1800s, one of our famous scientists went on to make ammonia in their lab. Ammonia till then used to be synthesized by living creatures. However, even after he did that, the name of this branch of chemistry did not change. It continued to remain as organic chemistry. If we talk about materials, elements, or atoms, carbon is the backbone of organic chemistry because organic chemistry cannot be even thought about without the presence of carbon. Yes, carbon does make varied bonds between hydrogen, bromine, sulfides, any other fluorescents, oxygen, iron, zinc. At every stage or every type of chemical compounds formed, there has to be one carbon atom in it. For instance, if I want to explain you it in this manner, the name of some of the organic compounds are decided based on to which carbon is the tertiary ring attached. So that makes my point further stronger that carbon is the backbone of chemistry. Carbon is said to form iron covalent bonds between two carbon atoms or one carbon and one hydrogen atom. Covalent bond means carbon can only share the electrons with the other part with which it is forming a bond. Sharing is only possible because the bond strength of carbon is very weak and the size of the nucleus is very small. So if it loses the electron or either gains the electron, then it would be next to impossible to handle carbon and to keep it stable. So if it shares electrons, it remains stable for a long time, and in some compounds it can also achieve the status of a noble gas. Now, since the bond between carbon is very weak, then you would remember from my previous lectures that since the bond is very weak, we have a very confusing kind of a reactions in organic chemistry, as in the reaction does become very slow, at times become very fast. So these kind of non-stereotypic reactions will be seen a lot in organic chemistry. In organic chemistry, normally the names of the compounds follow a typical order which is laid down by IUPAC. Similarly, the groups are also formed, and these kind of groups, if they share similar properties repeatedly, are termed as homologous group. The basic rule of homology is the, the change in calcium and or the change in the calcium atoms repeatedly is based on the properties. Normally, organic chemistry is that kind of a chemistry wherein with the addition of a carbon hydrogen bond CH2, another compound is formed and that goes on to exhibit different kinds of chemical properties. So, as and when any alcoholic or non-alcoholic compounds increases in size, their properties, physical properties as well as chemical properties, exhibit a lot of change. The common changes shown are when they were at a lower level, they used to be absorbed by water, they were easily soluble in water. However, as they become bigger in size, their solubility decreases because CH2 group leads to the addition of the acidic nature, or it makes alcoholic property, it starts exhibiting alcoholic property, then because of that, the chemical becomes slightly waxy and it cannot go ahead. Also, with the as and when there is an addition of CH2 molecule in the existing compound, the boiling point goes on increasing up to a certain part. However, if the boiling point increases up to a certain limit, after that it goes on to decrease. That is because at a stage wherein the boiling point increases is when there is a when there is a straight line addition in carbon and hydrogen bonding. However, straight line addition has a different kind of a limit. So as soon as the straight line bonding increases, the boiling point increases, but there's a limit to a straight line bonding in organic compounds. So as soon as that limit is reached, the boiling point again starts decreasing, because then the bonding moves to tertiary or branch chain. So, dear students, I will take this opportunity to let you know that today we are going on to discuss only till here. We'll see you next time very soon in another podcast where we'll be discussing about organic chemistry only. Thank you. Till then, stay safe, stay happy. Take care.